Okay, now we have about 20 minutes for questions and answers. Could all the early morning speakers today please come up and take a seat? In my introduction to some of the later speakers, I forgot to mention that they all play important roles in the Chapman Conference at the Chinese University. There is Peter, who was the chief convener of the whole conference itself and conceived the very idea of meeting with the meteorologists, archaeologists, and social scientists together in one room. And then Barry was a section chair for the interaction between the monsoon and the human civilization. And Bill Lau was the chair for a session on the modeling and observations on monsoon variability. So they have given you a brief synopsis of what has transpired during the one-week meeting, and this is now for you to respond. If you have any questions, you can address to anyone in particular or anyone in everyone in the group as a general questions. Could you please raise your hands when you have a question, please? Yes.
You mentioned, earlier presentations mentioned adapting to the environmental issues, and I think you were talking about the Khmer, and I was wondering if you could mention some of the things that went wrong and what we might learn from that about not making mistakes, or if we can learn from it. Maybe we can't. You know, there's just too many unknowns.
I'll try to answer that, but I think the sort of the simple takeaway message from that is that it was the Khmer civilization is an example of a highly engineered landscape where the adaptation, in a sense, then was all a way of adapting the river and the lake and the drainage system to the economy and the subsistence system, and so, but it was highly technological, and it worked during the period during the climatic period for which it was adapted, but then when the abrupt change, and it was a series, it was alternating flooding and drought. When that came, then they were sort of, it was over-engineered in a sense. It was over-engineered, and they weren't able to re-engineer it fast enough in order to support that size of a population. So when we talk about a collapse of a civilization like Angkor, it's not simply that everybody died. It means that the city and the civilization as it existed disappeared because they were no longer able to live together in these urban centers, so they had to move out into the forest. I hope that answers.
More questions, please. Yes.
So I'm completely convinced that we have strong evidence of massive monsoonal variability in the past and human adaptation and very compelling, robust responses at the zone level. But when I think about what society actually would want, it'd be robust predictions at a regional level on a regional decadal timescales. And if you begin to poke at any one of these subfields in the geological record, forcings that drove monsoon variability are completely different than what we have now. We have a unique CO2 rise that hasn't happened in the past 55 million years in terms of the rates. And also wondering about with, if you think about how past adaptation changes is feeding into what Professor Lau is doing, where are we in terms of being able to get knowledge at seasonal to decadal predictions at the local scale that is really relevant for investment in adaptation, societal adaptation and planning?
Okay, I'll try. I think in terms, we're probably in the very early stage in terms of trying to get all this information in place. I mean, right now, even in the scientific community, I think there is a tendency to work in certain area. We went quite far in terms of seasonal to interannual prediction when we think that we can rely on the INSO to predict monsoon. But it turns out, since the 1980s, that relationship is gone, and we're left with almost nothing. CY was telling me, and from an actual forecast, it was a good correlation when before the 80s, but after the 80s, and we know now we're just discovering that there are natural long-term modes in the atmosphere that the timescale, which is actually comparable to the global warming timescale. Warming is 100 years, so you are if it's all due to man-made, so it will be a rise. Okay, CO2 is rising quick, so your response will be just like this. But now we're finding that there are this, that just like this. So we may be seeing, so there is superimposition or interaction in all this forcing. So we're beginning to I mean, the system is so complex at this point that we are still grappling with that information. Before, we don't even know. We thought we can predict the monsoon with the signal. Now we know that it doesn't work anymore. So that's where we are. And I think it's very important that even within the community, that we need to be, the Chapman Conference idea is that we need to learn more about the paleo climate people. And at least we need to kind of talk about the same language. I mean, when they talk about weak monsoon or strong monsoon, we understand is this the same weak or strong monsoon that we're talking about? Because when you're dealing with regional issue, weak and strong monsoon is defined very differently from for example, record or something like that. So those are the kind of things we are not there yet. So that's still a long way to go. So one of the approach, at least for my own research group, is to really try to define the baseline for. I believe this CO2 warming is kind of a background signal there, but on top of so many things that are ongoing. So there is really no surprise, and when people talk about there's a global hiatus, so there's no global warming. Well, hiatus is something going on that somehow slow down that background signal, but maybe a couple of years, maybe 10 years later, then they're going to rise faster again. So it is a nonlinear system. You just can't expect the thing like this, that it is linearly just keep going. It will be just like this and that. And then you could have a volcanic eruption, and we know that a volcanic eruption can have a temperature cooling for years or two, and then it would just rise again. So all these things happening, and we'll be able to grapple with this Earth system that are so complicated, and we really don't understand, okay, to the best we can. So not a very optimistic picture, but that's where we are.
I should also add that among some of these natural phenomena that contribute to variability of the Earth's climate system on, say, decadal time scale, I think the ocean probably play a very important role. At our Chapman Conference, we didn't have too much emphasis on the ocean. Many of these changes that we referred to before 1980 and after 1980 probably is related to something going on in the oceans. And in our next Chapman Conference, maybe we should also invite oceanographers to join into this discussion. Yes, but
Hong Kong gets about 70% of its water supply by a pipe that comes from the East River just north of here. A lot of the rainfall that is caught in that river is associated with the monsoon patterns. We know that mainland China, Guangdong province, is developing rapidly and their requirement for water is increasing. So looking forwards, in the past, China had a lot of spare water to pipe to us. In the future, what will be the position? How might the monsoon alter the availability of water, and hence how well off we are in terms of taking it? What research is needed to help answer that question?
anyone want to answer?
Right now, in Asia, we are in a situation of wet in the south and dry in the north, okay? So, but global models, if you look at simply global warming forcing, you cannot produce that result, okay? Now, it doesn't mean that global warming is not working at it. First of all, those models, when you start to look at regional monsoon rainfall change, the reliability just become quite low, okay? I mean, you look at zonal average, bigger picture, then it's good, tropics versus extratropic. When you look at region, then they're not as good. But I think there are studies now, I mean, in terms of trying to figure out if people are now saying that this north drive south is probably relating more to the natural variability, something called the Pacific Decadal Oscillation. And there's some result which shows quite convincing that you can produce that dry signal to the north, signal to the south, but not from global warming signal, okay? But of course, any result produced can never be perfect. So if this is something, if it's decadal signal, at least we would know that it's not going to go away tomorrow, okay, or next year. So there may be some planning can be based on that kind of information, but we should have any information that the scientists provide should provide the uncertainty with that. And politicians or people, stakeholders can make decisions based on that trend, what you call trend, regardless is global warming or not. Let's not, sometimes people get caught up with the debate about global warming or natural variability. In a sense, that's not very meaningful from the point of actual policy or stakeholder. If something can, if no matter whether it's natural or global warming, if it is something can have that kind of persistent time scale, if this north dry, southwest persists for years, you have to do something about it, which give it the error bar. That's the kind of information I think a scientific community will provide to the policymakers and people interested with an error bar, whatever error bar is, and then the policies to make this. I don't think the scientists can tell the politician what they should do or not do. We will provide the best information we can with that quantifying uncertainty. So,
May I also add that Robert's question actually addressed a very important issue with the climate scientists, and that is how do we actually project the future on a very regional scale. We're now talking about the East River of the Pearl Delta region. And for that, you actually need to resolve the catchment area for that area. And that would require spatial solution for models approaching, say, 1 kilometer. So to do that, I think in a technological sense, is to embed a highly resolved model within a coarser grid that surrounds China, and then make predictions of what the future holds for this innermost grid. And I think that's where you obtain the information. Now the question now is, are we scientifically, technologically ready for making such a model work, and how much do we trust the output from such models? That is still on the forefront of scientific research. Right? There is a question, please.
Me back there? Oh, good. I'm Joel Lakin, Secretary General of the Independent Power Producers Forum. While based in Hong Kong, we function globally, around the world, and all across Asia. And what we're listening to today is, well, quite horrific. The impact of monsoon-driven climate change. That's a question I put to you. On power industry decision-making across Asia. Previous questions had to do with planning. Well, I want to be a little more specific, maybe difficult for you to answer it now. Certainly would love to engage some of you, all of you, in future dialogue with major think tanks we work with, like the Edison Electric Institute in Washington, D.C. The drought flooding on hydropower planning, which requires really big capital injection and long-term planning. Power planning on a country-by-country basis would be very helpful. You all remember the ice storm that happened in China, reaching down into Guangzhou, trapping 200,000 people in the Guangdong railway station, and an incredible humanitarian disaster. Nature has no sense of humor, and we had some input for the power generation industry. I'm talking about globally as well as Asia.
What was the question?
Well, I think that some of the geological record can help with this a little bit, because I was talking a little bit earlier about the records of flooding that had been started to put together in India. I'm not aware of any records like that in China, but having some understanding about how frequent they've been and how large they've been would really help with future planning. Certainly, the expectation of more extreme monsoon events of heavy storms and the frequency of cyclones should be important in planning this. We do understand that the steering of Western Pacific typhoons has changed over the last few decades to be actually less into the South China Sea and more along the east coast of China towards Japan. But understanding how those are going to change in the future would be very important too. And then also understanding the landscape response. One of the things I'm interested in is understanding, well, how does the landscape erode more or less quickly depending on what the climate's like. I mean, if you get more droughts, maybe you have less plants growing and the earth is washed away more quickly, more easily in the flooding events, and if that dumps more sediment into the rivers, that's going to fill up the reservoirs behind power generating facilities. I think the answer to this is a combination of using what we know about previous changes, both over the longer term, by which I mean maybe thousands of years, and also in detail over the last couple of hundred years, coupling that with the sort of predictive climate models that Bill Lowry's colleagues can put together. If we have some understanding using the past experience to try and predict the landscape response to monsoon changes. But I suspect it's going to be a hard job, though.
We are just a few minutes from the coffee break, but I would just entertain one more question from the audience, please. Yes.
Yes, thank you. This question is about the link between climate change and water. As we all know, in December in Paris, most of the nations in the world will be meeting to try to come to an agreement to develop a post-Kyoto Protocol world. And my colleagues in climate change policy tell me to their dismay that there's absolutely no official language about water in any of the negotiating documents so far. They're talking about emissions, they're talking about market mechanisms, but there's nothing about water targets, water advice, water policy that's linked to this new climate change policy document that they're trying to agree to. So my question for all of you, from your particular backgrounds, if you were sent to Paris in December, not representing your country, but representing your discipline, and you're asked advice on setting some sort of policy or targets or way forward when it comes to water in the context of this climate change agreement, what would you say?
I would say that we shouldn't be developing giant cities in places that already don't have enough water and are likely to have even less water supplies in the future, and that we need to improve flooding defenses in places where there aren't going to be water, since they may be more exposed to extreme flooding events in the future. So I'd probably, for example, in China, I probably would not like to see Beijing get a lot larger, given how dry it is in North China already. Sustaining huge populations there. Maybe more development in places where people can live more easily.
I would just add something to that. I think that one of the problems that we've had is in trying to solve our environmental problems. So speaking as an American, the Japanese have done the same thing in trying to solve our own problems. Since we've exported a lot of environmental problems to China, and we can't continue to do that because China is so large, and China already, I think I saw a figure that 68% of the rivers in China are so badly polluted that the water is undrinkable, and in many cases you wouldn't even want to touch the water. That can't continue, and so as part of that, I think we have to have international standards rather than national ones, and we have to think a lot more clearly about this this trend of exporting our problems to other countries.
May I just add one more thing? Water is related and is crucially dependent on the occurrence of extreme events. So the occurrence of extreme events could lead to very heavy rainstorms, such as that associated with typhoons and hurricanes. And therefore, we have to look into areas which are susceptible to these extreme events. Extreme events could also go the opposite way, and that is just prolonged periods of drought. What are the conditions that would lead to those conditions? All right, so now we are having a coffee break. You help yourself with the coffee outside, and please be back by 10:50, at which time the second session will start, and we will address socioeconomic issues. Thank you.